Hi, this is Ms. Jones, and we are going to be talking about solving the multi-step equations. So we're going to go through all the steps first, and then we'll look back at each one individually. Okay, so let's get started. In solving the multi-step equations, let's look at what the different steps are that you have to follow. The first one is to check and see if you need to use the distributive property on either side of the equal sign. Step 2 is to combine like terms on either side of the equal sign, and not across the equal sign, but on either side. All right. Step 3 is to use inverse operations to move all variables to the same side of the equal sign. So you want all of your x's on the same side. You don't want an x on both sides, like that. The next step, step 4, is to use inverse operations to move all of the numbers, constants first, to the same side of the equal sign. And then the last step, step 5, is to use inverse operations to isolate the variable. Okay, let's go through now and kind of break these different steps down, starting with step 1. So our first step in solving a multi-step equation is step 1, to check and see if you need to use the distributive property on either side of the equal sign. So let's look at an example of that. Okay, here is an example, and you are going to use the distributive property whenever you see a parentheses, and you're going to multiply the number in front of the parentheses times each term inside. You're going to multiply, because this is like 2 times whatever's inside. So 2 times 3x gives you 6x, and then 2 times a minus 5 gives you a minus 10. Be sure and always look at the sign in front of the number, and then you need to follow that operation. Okay, another example that I want you to make sure you keep in mind. Let's say you have a negative or a minus, and then inside of the parentheses you have something like 2x plus 7. Well, we want to use the distributive property here also, because you want to distribute this negative times everything on the inside. So it's kind of like you think about that understood 1. So you're going to do a negative 1 times 2x and a negative 1 times that positive 7. The plus 7, which is the same thing as a positive 7. And that gives you a negative 2x minus 7. We don't want to put a plus a negative. We want to just put a minus sign there. Okay, let's look at one more example of the distributive property before we move on to step 2. And here is a good example of that. Okay, so let's say we have 2. Looks like I'm liking the number 2 today. 2 times, and then let's just put x minus 4. And then on the outside of the parentheses, let's do a minus 6. Okay, so we're going to use the distributive property, and here's what I want you to be sure to do. You're going to want to multiply this number in the front times everything inside of the parentheses. Do not multiply it times this number on the outside. You only distribute to what's inside. So 2 times x, 2x, 2 times the minus 4 would give you a minus 8, And in this, you're just going to bring down the minus 6. Now the next step we're going to go into, which is going to be combining like terms. This right here is kind of an example of that, because these both, we want to combine those. So you would have 2x minus 14, because a negative 8 minus 6 is a negative 14. All right, let's go to step 2 in solving a multi-step equation, which is combining like terms. Now this one is very important, and very often students get confused. So let's look at some examples. Combining like terms is when you want to combine the same variable. So if you had 2D plus 3D, you would combine those and you would have 5D. 2 dogs plus 3 dogs equals 5 dogs. They're the same variable, the same letter, so you're going to combine those. All right, let's look at another one. Let's say you have 2E minus 4 plus 4E. Now here's the thing in this problem. You want to, once again, combine your like terms. And your like terms are the same variables. So that means I'm going to want to combine this 2E with this 4E. And that gives me 6E. And since that doesn't have an E, then you just kind of bring it down. And the really important part here, class, is you want to make sure that you bring down the minus 4. Always, every time, include the sign that comes in front of the number. I cannot stress to you how important that is. Here's another example, kind of like that one, with 6D plus 5 minus 2D. Now, when you're trying to identify which terms are alike, terms are divided by adding and subtraction signs. So when you're trying to decide which terms are the same, or they are alike, you might want to put a box around them, use a certain color, something like that. For example, here, I know that I'm going to want to combine the D's because those are the same variables. So I'm going to put a box around this 6D and a box around this minus 2D. Once again, guys, that's very important because both of these have the same variable, and you always want to include the sign in front of the number. And that gives me the 4D, and then you want to bring down the plus 5. Okay, the last example I'm going to show you with combining like terms before we go on is, what if you have a variable that contains an exponent? Well, I want you to think about this. When you have a PlayStation 3 and you have a PlayStation 4, those are two totally different things. And it's the same way with if you have a 4, oops, let me move this up a little bit. If you have a 4p squared plus a 4p cubed, you cannot combine those. Those are two totally different things. So this is your answer. You cannot combine any like terms because you don't have any like terms. They both have a p, but they have different exponents on them. Now, if we had a problem that was something like this one over here, and it was 3p squared plus 2p to the third minus 6p squared. Well, you can see in this problem we have a 3p squared and we have a minus 6p squared. Those are like terms because they have the same variable with the same exponent. So I can combine those. 3 minus 6 is a negative 3 p squared, and then I'm just going to bring that one down. Just like that. Okay, this has been part 1 of solving multi-step equations. In part 2, we're going to go into the inverse operations part and then go through some actual examples of solving problems that have multiple steps. Thank you very much.